solving exponential equations today. We're going to spend probably all of today and part of tomorrow on this. Okay, it's not hard. The really only reason I'm spending 2 days on it is because in this chapter we're going to start solving lots of different types of equations, and so we need to be really good with each individual strategy before we start putting everything together. So we're going to take the time to make sure that we are very good at doing this before we move on to anything else. That way when I add in each new piece, we still have a good foundation on how to begin with the problems. So on this, we are going to use the following property for solving exponential equations. It says, if you have an exponential equation with the same base on each side, then the exponents have to be equal. In other words, if I said like 2 to the 5th equals 2 to the y power. If these bases are the same, that means your exponents have to be equal. So y equals 5. Okay, seem reasonable?
What if there are two numbers?
If they are two different numbers, we won't be able to do this. So if they start out with different numbers, we will have to try to write them so they have the same base to begin. Alright, so let's take a look at some problems. Okay, so like Skyly said, these are two different numbers here. 3 to the x minus 1, or to the x plus 1 power equals 81. I can't just look at this and write down an answer. So my goal is to try to get the same base on each side. Now 3 doesn't break down at all. But can you write 81 as 3 to some power? 3 to the 4th power is equal to 81. So now I have the same base on each side. So that means the exponents are equal. So x plus 1 equals 4. Subtract your 1 and you get x equals 3. Nice thing about these, they are very easy to check. All you have to do is come up here. If I put this in, 3 to the 3 plus 1 power is 3 to the 4th, and that's 81. So you can always plug them back into the original to check. Okay. Alright, B. 2 to the negative x power equals 16. So, how am I going to rewrite this problem? 16 is 2 to the 4th. So you can drop your base, set your exponents equal. Divide by negative 1, so x is negative 4. Now, you'll notice I'm showing work on these problems. I understand you might be able to look at it and write down an answer, but we are going to get more complicated problems later on. So please get in the habit of writing out your work now so that when we get to the more complicated stuff, you're not trying to do everything in your head and making a lot of silly mistakes. Let's get another one. Thoughts? Okay. 1 over 25, you could write that as 1/5 squared. 1 squared is 1, 5 squared is 25. So then you can see the base is the same, so your exponents are equal. Some people really, really struggle when the bases are fractions. And if that's you, there is another option. You could rewrite 1/5 would be like 5 to what power? Negative 1. Okay, so 1/25, that would be 5 to the 5 squared is 25, that's where the 2 comes in. It was on the denominator, that's where the negative comes in. If you use properties of exponents, if you have a power to a power, what do you do with those exponents? So that means 5 to the negative x is 5 to the negative 2. And you get the same answer. So if you don't like the fractions, you can always write it without just by using that negative exponent. Alright, D. 2 to the 2x minus 1 equals 4. What are we going to do? 4 is 2 squared. So now the base is the same, so set your exponents equal. If I add my 1 and divide, we get 3 halves. You can get fractions and decimals for these answers. Are these okay? Some more complicated ones. Alright. 8 to the negative x plus 16 or plus 14 equals 16 to the x. Can you write 16 as 8 to a power? We can break them both down to 2s. So 8 is 2 to the 3rd power. You notice I'm writing that in parentheses and I'm going to put my old exponent on the outside. 16 is 2 to the 4th power. Okay, exponent rules. If you have a power to a power, what do?
Multiply.
So I'm going to distribute this 3. So negative 3x plus 42 equals 2 to the 4x. Now I have the same base on each side, so now you can drop the base, set your exponents equal. If I add my 3x, divide by 7, and we get 6. Check it real quick. Use your calculator, plug it back in, make sure you get the same thing on both sides. I'll make sure everybody knows how to check this thing. Never a dull moment. Alright, so do you guys all know how to check those? You plug them in, you got it to work out?
No.
Okay. F. What do we do now?
So you gotta take that 1/5 and make it
Put your
5.
pencil down and give
So
up.
negative 1.
Get out of my
I
class.
can do it. Anyways.
Okay, so 1/5 is 5 to the negative 1. Okay, so we know we would distribute that exponent, so you get negative x minus 4. The problem is, my property says if you have the base once on each side, you can drop it. Over here I have my base twice, so I can't just drop it. Do you have any other ideas? How? If I gave you 2 squared
What's my base?
times 2 to the third.
Maybe
2 squared means you have 2 2's. 2 to the third means you have 3 2's. Altogether you have 5 2's. When you're multiplying, if the base is written each time, the base doesn't change, you just add the exponents. So the 5 is written each time. I can put those together by adding my exponents. So x plus 2x would be 3x. 1 plus negative 3 is negative 2. Now I have the base once on each side. Now I can drop it. So add your x, add your 2, divide, and we get negative 1/2. Okay, so if I get a common base, I get 2 to the x plus 4. 8 is 2 cubed. So 2 to the x plus 4 equals 2 to the 3x minus 18. So x plus 4 equals 3x minus 18. So we get 2x equals 22. So x is 11. Second one, 9 is 3 squared. So you get 3 to the x plus 1 equals 3 to the 2x minus 6. So x plus 1 equals 2x minus 6. So x is 7. These good?
Good enough for homework.
Yep.
Let me do 2 more.
Oh.
Oh my god.
Is this all we're doing?
Today, yes.
There's
Oh,
no
I've
tricky
got this.
comments? There's no catch?
Got this.
Yep, there's the catch.
Oh, now we got work with E's. That sounds cool. And
Like
like
You're just the same, you just
Did you not?
Yeah. E is my base.
Yeah.
They have the same base.
You just drop it.
Just drop it.
So B squared
E is the most
equals
annoying letter in the alphabet.
You're an E.
Z equals 1.
So are you, Skylee.
Wow, Donnie.
It's Donald. Sorry.
Children, no more fighting.
Donnie.
We get x equals negative 4. We okay with that one?
Yeah. Okay.
Okay.
Easy as that.
Let me give you one more. I'm going to see if I can stump you.
But you can't.
You're not gonna stump.
All right. Now she's
You
gonna use her
can't
cheater
stop me.
powers.
One's gonna be
Okay.
A and one's gonna be B. Watch it.
Let's do.
Oh, she's making it up.
Uh-huh.
Yeah.
Now she's cheating.
Oh, that's not fair. Oh, you would.
Is this
That's
our homework?
dirty.
Is there stuff like this on our homework? Then this is unnecessary.
Are you serious right now?
Yeah, I am, actually.
I don't know. I'm not.
So what do I need to do?
You need to switch your thing 'cause I don't like fractions.
Well, let's switch it. What base do you want to go to?
32 to the negative 1. Up to
2.
1.
I'm gonna go home.
So 4 is 2
Squared.
squared. Okay, 1 over 32. If you're going to write it as a 2, it would have to be a negative because it was on the bottom. 2 to the 5th is 32. All right. Everything has to be the same base. I have to write 1 as 2 to some power. All right, so that means 2 to the 6th x times 2 to the negative 5 equals 2 to the 0.
You're so stumped right now.
No, I'm not, 'cause then you just add
Yeah,
them,
that
you
was
just add them.
so difficult.
Darn it. Get your homework done.
So 6x minus 5 equals 0. Add your 5 and divide by 6, and you get 5
Okay, we get our homework done.
So that's doable, that's not so bad?
No, we get our
Okay, there's a handout on Classroom.